Hello, today I'm going to go over the questions from atomic structure topic, and I'm taking this question from the book A-Level Topical Review H2 Chemistry from 2011 to 2020 examination questions. Question 1. A beam of particles contain protons and electrons. All particles approach an electric field at the same speed. Which diagram indicates the deflection of these particles? So the particles that have the lighter mass will be deflected more. Therefore, electron is going to be deflected more towards the positive charge and protons towards the negative charge, but not so much deflection. So answer is D. Question 2. Which element has the largest atomic radius? So if you go to the periodic table, bromine, indium, potassium, and rubidium are here. So as you go down the group, radius increases because there is more electron shells occupied. But when you go across a period, radius actually decreases because you have the same number of electron shells occupied, but increasing number of protons. So the attraction between nucleus and the outermost electrons increases. So the largest atomic radius would be rubidium. Question 3. This question is about elements with atomic number 3 to 12 in the periodic table. Which statements are correct for at least one of the most common isotopes of these elements? So for these elements, let's go back to our periodic table. Lithium has 3 protons and 4 neutrons. Beryllium has 4 protons and 5 neutrons. Option number 1, number of neutron is greater than number of proton. We have like this one. All right. Number of neutrons are greater than number of protons. And we also have number of neutrons equals number of protons. But we do not have number of neutrons less than number of protons. So the answer here is B. Which AR value of copper is given by these figures? So from the data given, we know that these two are the isotopes of copper, copper 63 and copper 65. Whereas this one is the value for gold. So if we want to find the AR value of copper, we just multiply the abundance with the mass number for each isotope and total them up. So here we have 63 times 65%, which is 0.65, plus 65 times 29%, or 0.29, divided by 0.65 plus 0.29. And that's because the total abundance of copper here is not out of 100. So the answer is C. Question 5. What do the ions of sulfide and chloride have in common? Both ions contain the same number of nucleons. Nucleon is the mass number. So they don't, because sulfide has a mass number of 36 and chloride 37. Both ions have outer electronic configuration of 2s22p6. So S has 16 plus 2 electrons, whereas chlorine 17 plus 1 electron. So we know the number of electrons they have are the same. So let's write down the electron configuration for 18 electrons. So it's not this. Both ions have more electrons than protons. So sulfide has 36 minus 16, which is 20 neutrons, and chloride has 37 minus 17 proton, that gives us 20 neutrons. So in both cases they have more neutrons, not more electrons. And the answer is D. Which arrangement of the 4 electrons of highest energy corresponds to the ground state of element in group 4? Group 4 means the outer shell electron must be 4. So here, this is definitely an excited state because the 2s orbital here is not full, whereas the 2p orbital is already filled. So this is an excited state. This B is a ground state. C is another excited state. We'll eliminate those. All right, so group 4, here the total valence electron is 4. Right, so that is group 4. But this one, quantum number 3, also has s orbitals. So if the 3p orbital is filled by 4 electrons, they must also have filled 3s orbital. Okay, so 3s2 and 3p4, that gives us a total of 6 valence electrons. So B is the answer. What are the numbers of electrons and neutrons in the hydroxide ion? So O 16-8, H 1 1 plus 1 electron, right? The number of electron is therefore 8 plus 1 plus 1 electron, right? That gives us 10. And the number of neutrons is 8 from oxygen and 0 from hydrogen. So that's 8. Answer is C. Question 8. Which particle has more proton than electron and more proton than neutron? So let's write down all the proton, neutron, and electron numbers. The number of proton here comes from 3 deuterium, so 3 times 1 plus oxygen, which has 8, so 11 proton. There is 1 neutron per deuterium, so we have 3 times 1 plus oxygen has 16 minus 8, which is 8. So this is 11 neutron. And electron, each deuterium has 1 electron, and each oxygen has 8 electrons, but this species is a positively charged ion, so you take away 1 electron from there, so that gives you 10. Right, so you work out the numbers first for all of these species, and the answer is B. Which particle would, on gaining an electron, have a half-filled set of p orbital? So we write down the nucleon number and the proton number first, and we now write down the electron configuration. When gaining an electron, the species will have a half set p orbital. Now when carbon ion here gain 1 electron, the p will not be half filled When nitrogen gain 1 electron, it will also not half-filled, neither will the ion of silicon, but the ion of phosphor here, P plus, will become half full. Right, so answer is D. Question 10. The first ionization energies are given here. M forms its only chloride by heating M with chlorine. What is the occasion of the formation of chloride of M? So first, we have to know which group M belongs to. So find the most significant jump here. Yeah, from 600 to 1200, that's a jump of around 600. From 1200 to 2200, that's around 1000. So the largest jump here happens between the fourth and the fifth ionization energy. This tells us that M is in group 4. Okay, so each M will bind to 4 chlorine. C is the answer. Next, which particle contains a single unpaired electron? Let's draw the structure. One of the particles formed after the heterolytic fission of chlorine molecule. So chlorine molecule looks like this. Heterolytic fission means one of the chlorine gain all the electron pair here, but the other chlorine doesn't gain anything. So you would end up with Cl with only 6 electrons with a positive charge, and the other Cl has 8 electrons and a negative charge. Ammonium ion forms 3 normal covalent bonds with 3 chlorine and 1 covalent coordinate bond with another chlorine. Okay, so I'm going to draw this covalent coordinate bond, and it carries a positive charge. The copper ion in copper oxide, copper here is 2 plus. Copper has 29 electrons, so let's write down the electron configuration. Remember, copper's electron configuration is rather special because the 4s orbital is half full and the 3d orbital is full. So when we want to make copper 2 ion, we take away 2 electrons, first from the highest quantum number, which is 4, so we take away 1 electron from there, and we take away another electron from there. So we have our 3d orbital looks like this. Which particle contains a single unpaired electron? This one doesn't have any single unpaired. These two also don't have single unpaired. All of these electrons are all paired, but this is a single unpaired electron. So answer is D. Question 12. Which of the following does not contain either an unpaired s electron or an unpaired p electron? So write down all the configuration. Okay, this is an unpaired s, unpaired p, and then this subshell has an unpaired electron 1, 2, 3, 4, 5. So this is unpaired, whereas this one, the s is full and the p's are full. So answer is D. The graph shows the first 13 ionization energy of element X. What can be deduced from element X? Okay, first 13, it doesn't say that there are only 13 electrons. So there might be more. But let's determine the number of groups, because after the removal of the first two electrons, there is a big jump in the ionization energy, and that tells us that this element has two valence electrons, so it is in group 2 of the periodic table. It is not a D block element because for transition metals or D block elements, you probably won't see a big jump or noticeable jump like the one that is here, because between 3D to 4s orbitals, the energy gap is very small. As you go to a higher quantum number, the energy difference becomes smaller and smaller. So you may not see the noticeable difference between the ionization energy of one electron shell to the inner electron shell. It cannot be the second period because this element has at least 3 energy levels filled. Right? So this is 1, 2, and 3. Answer is B. Next, titanium 4 oxide is composed of titanium 4 plus and O2 minus, two of them. Titanium is here. It has 22 electrons, and we wanna take away 4 electrons. So that makes 18 electrons. Number 15. Why is the first ionization energy of neon is higher than that of fluorine? Neon has 10 electrons, whereas fluorine only has. They both occupy the same number of electron shells, which is 2 because they're in period 2. So it means that neon has a stronger nuclear force compared to fluorine. D is the answer. Section B, question 1. In which series of elements do the atoms have the same number of neutrons as protons? So helium, carbon, magnesium, they all have the same number of neutron and proton, as do the elements in number 2, but not sulfur here. So answer is 1 and 2. It's B. The structured questions now. State the full electronic configuration of potassium and copper atoms. Potassium have 19 electrons. Copper, remember copper and chromium, they have a special arrangement. And this kind of arrangement where the s orbital is half full and the d orbital is full or half full, this gives copper and chromium a higher stability. Explain fully why copper is much less reactive than potassium. Okay, if you look at the data booklet, first ionization energy of potassium is 418 kilojoule per mole, whereas copper is 745 kilojoule per mole. So that means more energy is required to remove one electron in copper from its valence electrons. And the harder it is to remove an electron, the less reactive the metal. Another data that you can find in the data booklet would be the radius of the atom. Radius of sodium is 0.186 nanometer. Now the data booklet doesn't give us the radius of potassium, but radius of copper is 0.117 nanometer. We all know that as we go down the group, the radius of an atom increases because there is more electron shells occupied. So, radius of potassium must be larger than radius of sodium, which is larger than radius of copper. So, copper here is less reactive for a few reasons. The first one. The second reason, both of these differences, while having similar shielding effect to that of potassium, because they both occupy 4 electron shells. And so these two factors lead to the stronger attraction between the nucleus and the valence electrons. Alright, that's it for today. Thank you.